Hi, my name is Wayne Chang, and this is Cody Akins and Claudio Ariano. We are the double B side of the UTDesign and Mexico Senior Design Project. We're also working with our faculty mentor, Dr. Hoker from the ME department, and our corporate sponsors are Keith Barber and Ben Susi. Before we get started, I just want to say that we are under a confidentiality agreement, so that some of our explanations are intentionally vague. The need for this project arose from previous PepsiCo research that indicated a correlation between the acoustic emission created from crushing chips and texture qualities that PepsiCo desired. However, their old implementation for testing this was both inefficient, expensive, and couldn't be used on the line and could only be used in the lab. So our project was to create an automated on-the-line instrument that characterizes snack chip texture using the acoustic generated from crushing chips. As far as electrical requirements go, because PepsiCo wanted a machine that was easily repairable and maintainable, we were not allowed to build any custom electrical components. And because this is an on-the-line machine, all exposed components will be subject to the same sanitation requirements as any other on-the-line machine, including caustic wash. So our components all must be caustic wash down safe. The original design had PepsiCo doing their DSP on a separate PC. And they wanted to streamline this, so all of our DSP is done on an onboard single processor. Finally, all of our results will be able to be logged onto a SQL server. Our mechanical design consists of a preprocessor that takes whole chips, crushes them through crushing teeth, and sieves them through a trommel sieve so that we have a uniform sample size, which is then fed into our main assembly, which is a through-station rotating carriage. Consists of a fill station, a crushing and data acquisition station, and an evacuation chamber. This is all controlled with the National Instruments Compact Real Controller. It uses several I/O modules to do the signal conditioning so that the controller can do the system control and the DSP. There's also an element of noise cancellation because the factory floor is fairly noisy. This will also be done on the signal processor. As far as where we are now, our mechanical design is roughly 80% complete. Our hardware design is around 90%. We've started our software development, and we are preparing to order parts to create our first prototype. Successful implementation of this device will give PepsiCo a competitive advantage by allowing them to consistently and accurately test the texture qualities of chips as they come off manufacturing lines. Any questions?
So why acoustic-based texture testing?
We can't disclose too much about exactly what that process looks like. Essentially, we can tell you
the process itself, but why acoustic-based? Why not?
There's a strong correlation between the acoustic sound that's created and the texture. Current methods to test texture are basically done by human panels, which is extremely inefficient. It takes a very long time. So there's a good quantifiable way to do that.
And then you may or may not be able to answer this question. Do you guys look at what are you measuring and what are you looking for?
Can't tell you that. Sorry about that.
So what's new? You said this was a follow-on to an existing system that they have. What's new from you guys that you've added?
The current test setup is kind of a jumble of a bunch of different components that are kind of thrown together, essentially. It's kind of a crude mechanism that they kind of sort of threw these together. So ours is specifically designed for this purpose and is specifically designed to be used on the manufacturing floor versus just in the laboratory.
Can you comment on the cost of this new versus old? Did you add it cost or did you?
Yeah, we can't tell you exactly how much. I can tell you that there's an extremely significantly less than the current machine is more and it's only laboratory safe, whereas ours would be cheaper and available for manufacturing use.
Can you share some thoughts about project management by having a relatively large team, I think totally 6, and different disciplines? 3 of you are from electrical engineering, 3 of you are from the mechanical engineering. How to organize the work, what project leader
how was the project distributed between you two?
Honestly, I feel like we pretty much share the work. We're kind of on the same page. We kind of discuss all different things as far as who does what work. So like for the software breakdown, so I'm going to handle all the motion control, all the FPGA programming for the system. Wayne's going to do all the user interface type stuff with us and the data logging. Claudia's going to